G'day, g'day. Rooting around a couple of different speed sensor options. Over here on the Arduino board I've got an optical tack. So it's just breaking the optical there with that little doodah there. I've actually got a PID loop running that motor. Even found an old screen from 20 years ago sitting in the heap. Well, roughly 20 years ago. To monitor the PID, how it's performing, and obviously I can change the set point on a little pot here. Well, one thing I found interesting with that Arduino setup is it doesn't stop integral wind up no matter what you try. So over here I've actually put the integral number for this particular job, and I've actually made a thing to stop the integral wind up. Otherwise you'd wind the speed set point down once it maxed out and take an eternity come down. Anyway, so that's one speed sensor. Then I've got my trusty Rotax 2-wire speed sensor. Here's another one out of a RC Heli setup. Here's it in the motor. This is a 0.9 cubic inch, about 3 horsepower these little guys are. It's about 4 times bigger than what the RC cars are, and it's just that sensor there. And typically these have a magnet installed in the fan. That one didn't, because that one's brand new. Here's one that I've put on the end of the drill for some testing purposes. The next type of speed sensor I've got is this guy here, which is a little bit like the Rotax one. It doesn't require a magnet. This one's actually pretty cool because it actually fits up inside the back of the crankcase and shoots through the aluminium onto the crankshaft. So if you can imagine this guy here just without one side connected, so it's staring through the aluminium case into something like that. These two sensors look quite similar, except this one's actually got a magnet, a bit like the Rotax one, has a magnet embedded in it. So both these two types have a magnet embedded in it, and that helps, means you don't need to have any magnet on the target. You can just measure the change in ion directly. And so like the Rotax one, it's measuring on the back of this gap in here. Whereas these guys here require magnets. So done some testing with this guy to see what it can do. So I'll pull out my speed feedback on the little motor over here and plug in the Hall effect speed sensor. Seems to be running. 0 feedback. Now these are all very much dependent on the way your north-south facing of the magnet, so you've got to be careful you get the right one. Not drop it. So that's the right way there. Plug that on the tester. I don't know if I can do this with 2 hands. And got me drill with me magnet attached to it. And over here I'm reading up to 900 RPM. It's actually 1800 just because I've got the settings wrong in the software. I guess I can test that with this old GV1 governor for helis. So I might unplug that out of the board and just check it in this GV1. Okay, got the sensor hooked up to the GV1. Drop the phone. Give the drill a bit of a spin. And that's about right. The 180 RPM that you saw then, that's actually 1800 because the GV1's got a gear ratio thing that you can type into it, and I've just selected 1 to 10 gear ratio. Another thing cool about this little GV1 is it actually gives you sensor things of the voltage. So if I hold it there, I can get it to start to move about 1 centimetre away, half an inch really, and that's right up on the money there. So got me sensor about 3 mil away there, and full signal strengths. So, you know, with this magnet, the strength of it, I could quite easily run this thing 5 mil away without any drum at all. Incidentally, the old magnets we used to use in the back of these, even right butted up, they would only get about 80. I got 90 then. I guess the question is, we'll use that for one of these. What do you get? You get some pretty good numbers from massive distances. You don't get any weirdness as it goes past either. So it's a nice small sensor. And I guess if you wanted to, because this is nice and wide, it'll be the good gap in your sensor if you wanted to, and then you could probably either just use one, or you could mount several other ones along the way to give you a better crank position. Not really sure what to do there. Could always just bang one of these in the side, drill a hole in the side of that, smack up against that. Wouldn't be stupid.